Now, since rational expressions are really just fractions, then everything we know about fractions can be applied to them. For example, we can talk about writing a fraction in lowest terms, or it's sometimes called reducing a fraction. If I just look at the rational number 4/6, how can I reduce this or write it in lowest terms? Well, by observing that both of these have a factor of 2 in common. 4 is 2 times 2, 6 is 2 times 3. And I can observe that because I just factored the numerator and the denominator. Well, now that I know there's a 2 in common, what I can do is divide that 2 out. This is sometimes called canceling. And so all that I have left is the 2/3. So 4/6 in lowest terms is 2/3. We can apply the exact same process to rational expressions to write them in lowest terms. Let's say we have 2x minus 4 over 2x plus 6. Okay? Well, just as we did here, we need to see if there are any factors that the numerator and the denominator have in common. So what we do is we factor the numerator and we factor the denominator, just like we did here, except we're factoring polynomials. 2x minus 4, how does that factor? Well, there's a 2 in common to each term, so we can factor out that greatest common factor. X minus 2 is prime, so there's nothing more to do to that one. Denominator is 2x plus 6. Again, there's a 2 in common, so we can factor that out. Okay. And so now that we've factored it, we can see there's a 2 that's in common to both of the numerator and denominator. So just as we did here, we can divide that 2 out. And what we're left with is the x minus 2 over the x plus 3. These two expressions are equal in value. This one involves the smallest possible integers, and so it is called lowest terms. Okay? Let's look at another example. We'll take 4x squared plus 12x plus 8 divided by x squared minus x minus 2. Okay? We want to write this in lowest terms. Well, again, same process every time, just like with the numbers. Factor the numerator and the denominator. Divide out any common factors. So we factor the numerator and denominator. This numerator has a 4 as the greatest common factor in all terms, leaving my other factor to be x squared plus 3x plus 2. Okay. There is no greatest common factor other than 1. Okay, well now we need to do a little bit more than what we did up here. We need more than just the greatest common factor. We need to factor this trinomial. Well, x squared plus 3x plus 2, by factor pairs, we can factor as x plus 1 times x plus 2, because 1 times 2 is 2, and 1 plus 2 is 3. The denominator we can also factor by factor pairs. It's going to be x minus 2 times x plus 1, because negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So now that it's factored, we can see that this x plus 1 is a common factor in the numerator and the denominator. And so we can divide it out just as we divided out the 2 in this example. So what we are left with is 4 times x plus 2 over x minus 2. And if you like, you can multiply this through. You'll get something that's equivalent, 4x plus 8 over x minus 2. Either one, they have the same value. A couple little issues that you may want to watch out for. This first example gives us a rational expression in which the numerator and the denominator are both prime polynomials. They cannot be factored any further, and so they're not the same, so you might think that this is already in lowest terms. But you have to remember that you can always factor out a negative 1, and if you'll notice, the numerator and the denominator are identical except that their terms have opposite signs. 2x, negative 2x. Negative y, positive y. So what we can do then is factor a negative 1 out of the numerator. And I'm going to go ahead and rewrite this so that it looks the same. We don't have to, but as long as we recognize that these two are now the same polynomial, I can divide out that common factor, and what I'm left with is just negative 1 over 1, or negative 1. So anytime you have a factor in the numerator and a factor in the denominator that differ only by a factor of negative 1, you can divide them out by taking that negative 1 out first. So that's one issue that can arise. The other issue is a common mistake that you need to be very diligent to avoid making. Back to our first example, 2x minus 4 over 2x plus 6. What we did to solve that, or to write this in lowest terms, is we factored a 2 out of each one. Then we were able to divide out the 2's because they were a common factor. But some might look at this and say, well, wait a second. There's a 2x and a 2x it has in common. So I'll just divide those out. And hey, negative 4 over 6, there's a 2 in common there. So I'll divide the 2 out and get negative 2/3. Well, remember what we actually got when we did this. We factored the 2's out. We divided out the 2's, and so we got x minus 2 over x plus 3. This is not the same as this. Somewhere these x's got lost. Okay? And so how do we know which one is right? Well, let's evaluate. Okay? And we have to be careful to pick a good number. If we pick 0 for x, then of course these two are going to be the same. But so let's pick something else. Let's say x equals 1. If we evaluate our original expression for x equals 1, then we get 2 minus 4 is negative 2. 2 plus 6 is 8. And that, when we divide the common factor of 2 out, gives us a negative 1/4, which is not equal to negative 2/3. The whole point of writing in lowest terms is to get something that's equal in value but simpler to work with. These are not equal in value. So we know this was wrong. We can't cancel these things out like that. Okay? Whereas if we put a 1 in here, we get 1 minus 2 over 1 plus 3, which is negative 1 over 4. And look at that. They match. Because this expression and this expression are equal in value. Okay? So what happened? Why can't we do this? What's the difference between dividing out or canceling out the 2x here and canceling out these 2's here? How can you tell the difference? The difference is that here, these 2's are multiplied by whatever else there is. In other words, they are factors. Okay? When you factor your polynomials, you break them up into products of smaller polynomials. So it's nothing but multiplication going on here. That's not what's going on here. 2x isn't being multiplied by negative 4. These 2 are being added or subtracted. Okay? That makes them terms, not factors. We cannot cancel terms. Okay? We can only cancel factors. In other words, we can't cancel things that are being added or subtracted. We can only cancel things that are multiplied. That is the fundamental property of rational numbers.